Hello all, welcome to my channel. I'm back with another video. In this video, we will be seeing how to approach data engineering system design interview question that you might see or you might be asked in an interview. So let's get started. So any data engineering system design interview, we can answer that question following a distinct approach. The approach is to first do the requirement gathering, then we ask some clarification questions, and then we start to design. So what are the questions that we should be asking? So if we see this mind map that I'm going to explain, this will have all these things that we need to check before we answer any data engineering system interview question. So for example, these are the high level things that we will be discussing in this video. So for example, what are the core consideration? We will ask the data characteristics and its evolution. What are the architecture and anatomy layers? Once we have those things, then some of the critical components, traffic management and optional system layers that we will have. So if we start at core considerations, we will have volume. We should ask what is the volume, what is the velocity at, then we should be asking uh, access patterns, then we will be asking common system needs. So these are the questions why we need to ask this question, because based on this only we will be making certain decisions. For example, let's say the volume. So volume, if we have based on the volume, we decide the storage strategy, whether it will be a DB, which will be object storage, that becomes, because if we have a high intensity or highly it's like the data is coming at very fast rate. Let's say instead of getting um, an information on let's say file basis, we are getting data from, let's say, some sources like IoT devices and so we can't store it in a file. We will have to store it in some DB. So that volume and the amount of volume or the amount of the speed at which the data comes, that will decide whether what the DB size, which choice should be, and what should be the operating mechanism of this solution that we are going to build, whether it will be a batch or it will be in a streaming solution. But let's say if we are getting files every 30 minutes, then we can store it in batch mode. But let's say if it is coming as an CDC event, we have to do something like a streaming use case. So these are two very common, the very important aspects to ask. One is volume to decide the storage, and another one is velocity to decide the mode, whether it will be batch or streaming. So let's go to other layers now. So once we have volume and velocity covered, we will ask some common question needs like, is there any burst or any spike that is happening, or is there any back pressure that we need to handle? Because if we have high velocity systems, we need to do a certain kind of back pressure as well. Do we have to do rate limiting? Do we have the use case of backfilling? For example, it might happen that we have missed certain loading, and then do we have to do a historical load as well? Or let's say we do process the online part in on let's say streaming mode, and at the end of the day, do we have to populate the DB again for the whole data? So that is something we have to understand. We also have to understand idempotency, like whether we can replay the events, or we can if we just rerun the pipeline, will it cause any issues? Can we make the systems idempotent so that we doesn't happen? uh, so that way we have to find these things. We ask these questions. Then we also ask the questions about whether the system is read heavy or write heavy. Like the read heavy systems are systems which require a lot of what you call uh, reads rather than a lot of writes. So these are the systems where we write less frequently and read more. So for example, dashboards. And write heavy systems will be like where we are updating the data more frequently than reading it multiple times. That can be, let's say, offline records, batch records, files that we have to send to certain other stakeholders. So that becomes based on that we have to decide what kind of uh, things that we need. For example, a read-heavy system will require a faster response, and we have to model data storage for access rather than doing it for writes. And in case of write-heavy systems, we can go ahead with append-only systems, which is, let's say, log structure merge tree, so that the writes are faster. Same way, if we are, let's say, having a lakehouse solution, for example, let's say we are looking at Iceberg or something like that, we have copy on merge versus copy on write. So uh, in a write heavy systems, we will be going ahead with copy on merge, and for read heavy systems, we will be going ahead with copy on write, so that our reads are faster. So these are certain things that we have to take care when we are doing or dealing with the core considerations that we have to consider while we are doing a data engineering system design question. Then we have certain data characteristics that we have to also understand. For example, the data freshness windows, like will it be real time versus near real time? We want a consistency at an acid level or base level. For example, acid is something which becomes consistent this once we write. Base is when we think that okay, we can write it and later on it will be reconciled, and the base stands for basically available and eventually consistent systems. So that is the base one. And do we have duplication needs, like does the data is having any duplicates that we have to take care of? So those will be data freshness windows, and duplication will happen in the window. Let's say, for example, can we have a transaction which is retried in, let's say, last 5 minutes? It's a duplication case. But can we have a transaction that is retried after, let's say, 1 hour? That doesn't make sense, because in 1 hour we will have a timeout or everything, or the customer might not do the same transaction. So that deduplication is not needed, but deduplication will be needed if we are doing, let's say, in a shorter time window. So that also uh, mm, goes into the data freshness window part. Then we have evolution of data, whether the data changes over time. For example, the dimensions keeps on changing, or for example, are we doing any CDC or change data capture that we are doing? So that kind of thing also we have to do it in the evaluation of the data characteristics part itself. Also, data distribution is important. We have to find out whether do we see any hotkeys while we are doing ingesting the data. Is there a chance of any skew, or is there any non-uniform data that is coming into the system? So that are the data characteristics evolution that we have to check. And once we have these things with these consistent core consistent and data characteristics identified, then we go ahead and try to build a system. Uh, the solution to this is based on certain things. For example, we'll have two layers. One is the control plane, one is the data plane. Control plane is what orchestrate everything, and data plane is actually where the data sits. So for example, we can say that any API that we create is kind of a control plane, but the data DBs or schemas where we have put that data in, that becomes our data plane. Or in terms of, let's say, we are building a data platform. So for example, take example of Databricks. So it has a control plane where all the workings of the platform is hosted, but we have data plane where actual computation happens, let's say S3 bucket or the warehouses that are there. So that differentiation is very much needed. Then we have ingestion layer. Then ingestion layer, we decide sources, like it is database, files, APIs, event streams, or IoT devices, and their characteristics, whether data that is coming. That's where the consistency that we have, data volume, latency, format, change data category, etc. Those things are handled in the ingestion layer. So once we have this ingestion layer sorted out, we move over to the persistence layer. So persistence layer is where we actually persist the data. So once we are getting the data, we will decide the mechanism how to ingest the data. Then we have to also persist it. So persistence means storing it somewhere. So the storage can be warehouse, lakehouse, or stream house for the streaming use cases. And we can have Medallion architecture where we first dump the data into bronze layer, then we do the transformations, move it to silver layer and then to gold layer. So that also can be one data staging area. And also at that time, we have to decide the dimensional modeling, like when we are getting the data, how we want to store those data. Because if we are collecting some facts, it can be in the fact table. If we are collecting some dimension, it can go into the dimension mode. So that fact and dimension modeling can be one approach. There are other dimensional modeling approaches as well, but we have to decide that in the persistence layer. Then we have the processing layer. The processing layer will simply do is move the data or transform the data to a consumable format. So it becomes, let's say, for example, if we are using the Medallion architecture from bronze to silver to gold, how the data moves and how it is transformed, those things are taken care by processing layer. And the processing layer will have we have to decide what kind of processing that are we doing batch, are we doing linear real time stream or hybrid solutions that we are going to take. And also there we will be deciding on the tools, like what processing tool we will be using, whether it will be Spark, it will be let's say a single node system, multi-node system, distributed systems, Daft, Ray, all those things comes into this processing layer part. Then the consumption layer is where uh, we ask the end user that how they want to see the data. So this can be also part of the initial core consideration as well, or somewhere in between as well. So generally for systems which we are offering as a platform, we take this in the later phase. But in case of we are building something for the end user itself, then this questions has to be asked beforehand. But the questions will be like how much scale, what format do you want the data, what is the freshness that you are expecting for the data, what is the volume that you will be fetching out of. Let's say if we are creating a data API, we can't go ahead and say that okay, our API will serve, let's say, GBs of data. So we will have to provide an file download mechanism. So those kind of things is very much important. Then consumption layer also comes along with a semantic layer that we have to add. Semantic layer is nothing but a unified business definition of certain terms rather than looking into each of the actual physical definition of the terms. For example, if we can say that, okay, give me a KPI, business KPI, and how that business KPI translates to different tables, or from where it is getting fetched, how it is getting fetched, it's totally abstracted from the user. That's where this semantic layer comes into picture. Then we have also to identify the persona of the user which is consuming this, whether it's those are analysts, they want data in, let's say, some tabular format, BI model, whether they are engineer, they want the APIs, they want the data, they want certain analytics on top of it, whether it's an app which will do automatic consumption rather than any human intervention in order, or it is an external integration. For example, if we are using providing, let's say, Razorpay, it can have a solution which is called Razorpay X, which provides added services to its transaction mechanism. So those services will not be directly consumed by a user. It will be via an external integration. So that are we building for that? So that also persona identification in the consumption layer is something very important. Then comes the orchestration layer. So orchestration layer has, like, for example, we can have certain functions or tools to decide how the components talk to each other, and some tools can be airflow, can be step functions, or any other. For example, it can be temporal as well. So based on the structure or the strategy that we are thinking and the pros and cons, that based on that we will decide whether we want which tool to choose for orchestration, doing the orchestration. So that's another layer. Once we have done this architecture and anatomy layers, we go back to the critical system components. So what are things to keep in mind while deciding the solution is the idempotency. We need to ensure that our system, our processes are idempotent, so that we don't have a side effect when in case we are trying a retry. Do we need CDC capture? Are we going ahead with incremental loading? Because incremental loading is something which requires less resources and it keeps on updating the values rather than doing a full refresh. CDC helps us in doing incremental loading. Then we will have to come up with data quality checks and the governance, what we will be doing for the each layer. So for example, let's say when we are translating data from bronze to go silver, what are the sanity checks? What are the data quality governance checks that has to be added or that has to be addressed? That those are the things that we have to decide on. Uh, then also we have to understand the schema validation and evaluation. So that becomes another critical component, that concept that we need to understand and ask the interviewer or tell about when we are building the solution. Then we have traffic management. So there are for examples whether we want a fan in, which is funneling, or we want fan out, which is on notification based of solution. Fan out is also something where we say that okay, we get one event and then we fan it out to multiple processes. For example, uh, uh, one example can be, let's say we are building uh, let's say we are building a report generation system which generates the reports based on the transaction done by a particular user in their trading platform. So instead of doing it at one go, we can fan it out. And let's say the fan in process will be when the user, let's say, does let's say from the MF Central point of view, a user does he or she might have different vendors. For example, they might have portfolio on Grow, they might have portfolio on Demat account as well, other Demat account as well. Let's say Zerodha. So they do certain transaction in both the places, but instead of getting generating reports individually for them, what MF Central does is whatever is or CDSL does it combines the total days records and then sends it to the user. For example, CDSL or NSDL both can do that. So that becomes a fan-in approach. So what kind of traffic management that you want to do is just that decides whether we are going with fan-in or fan-out. And then also we have decoupling. For example, we want the system to be decoupled. For example, an event notification comes and then certain processes start. So that decoupling can be done using Kafka or Pulsar or any message bus. For example, RabbitMQ can also be used for certain message-based protocols. Then once we have these things, we also have to certain optional system layers that we need to discuss with the interviewer to tell them that what we are going to do with the tooling layers. For example, how we will be doing infrastructure code, how we will be doing containerization, how the data versioning is mentioned, how CI/CD is done, whether we are, let's say, if we are on Kubernetes, are we doing it with Argo or when dealing with SQL databases, or let's say DBT, how we integrate that with Liquibase, how it gets deployed via Jenkins. So that kind of CI/CD consideration also needs to be done. Also, there is a data catalog that becomes very interesting thing to note. Once we have processed the data, it needs to be easily searchable. So how we integrate that with data catalog, that becomes one tooling layer. uh, Certain data engineering concepts will require certain ML and AI layers as well. For example, let's say if someone says that okay, build a recommendation engine. So once we have the data processed and which we have the features calculated, how to add an ML layer on top of it. So we have to discuss the ML model that we will be choosing, how model registry where we will be storing the models, a feature store, how to store like online and offline data, and then dimensional modeling again comes into picture because ML, while doing the inferencing, we will be doing some joins and trying to find out certain data. So in that case, dimensional modeling also helps in there. Then we will have to add certain observability layer, like what data quality framework we are using, what kind of alerts and notification we are sending, are we doing FinOps, like cost observation for the data. And then we have KPIs. So the KPIs are something which says what will be the SLA, data freshness, threshold, and everything that gets calculated. So those are certain things that we will have to understand and we will have to explain when we are in a data engineering interview. So these are certain things that are needed and that helps us in building or answering the right questions and finding out the right solution to certain questions so that we are confident enough to answering things when we are in a uh, data when we are in an interview which is related to the data engineering and system design. So that's what I wanted to cover in this video. If you like it, do share it and spread the word. Have a nice day. Thank you.